Hey gang, it's your favorite teacher Arjun again, here with some endocrine anatomy. As with our other videos, we here at First Aid like to ask questions, and it's not because we like to hear ourselves talk. Even though you could wait the 1 or 2 seconds it takes to hear the answer, I strongly encourage you to try to come up with some of the answers on your own. It'll help keep you engaged and give you sort of an idea of how well you actually remember some of this stuff. Endocrine anatomy's not too intense, so let's dive right in. Let's start with our friends the adrenal glands sitting right on top of the kidneys. A quick gross anatomy rundown. Venous drainage differs by side, much like the gonads. The left adrenal drains into the left renal vein before it hits the IVC, whereas the right adrenal drains directly into the IVC itself. Arterial blood supply is threefold and comes from the phrenic artery, the aorta, and the renal artery. It's not the best diagram, but actually it's the venous drainage that ends up getting tested most often. Identifying the adrenals on a CT can be a little bit tricky, especially if you're used to seeing images like these that represent the adrenals as purely superior to the kidneys. I'll give you a moment to play Where's Waldo with the adrenals. Try to locate these for yourself. And by the way, ignore this huge gallstone. We'll call that an incidental finding. As you can see, they're not only superior, but also anteromedial to the kidneys. Remember from renal that the left kidney, and thus the left adrenal, sits a little bit higher than the right. Now normally they look a little bit like the inside of a Mercedes-Benz logo, but as always there's a bunch of fun pathology that can make them look pretty wacky. Now it'd be pretty sadistic for the step 1 folks to make you identify adrenal pathology on CT, but if you know what a normal adrenal gland looks like, you should be able to identify a gross abnormality like a mass, in the event that they ask you to identify one. So that's gross anatomy. Now let's take a cross-section of our friend the adrenal gland and pick it apart from the outside in. The adrenals are surrounded by a fibrous capsule, but the most important structural and functional distinction is between the steroid-producing cortex and the catecholamine-producing adrenal medulla. The cortex is divided up into 3 zones, each one of which contains a different arsenal of enzymes to generate a different set of steroids. From outside to in, the zones are named glomerulosa, fasciculata, and reticularis. Remember G, F, R. Like the kidneys, they're sitting right on top of. These zones are responsible for the production of mineralocorticoids, glucocorticoids, and weak androgens, respectively, which regulate salt, sugar, and sex. They say the deeper you go, the sweeter it gets, because as we all know, sex is hilarious. But real talk, the activity of these hormones is a lot more complicated than just salt, sugar, sex, so we'll go into them in a lot more detail in the physiology section. Now this is more of a physiology point as well, but it's worth asking. What hormone do you expect is the primary regulator of the steroids produced by the adrenal cortex? Hint, it practically has adrenal cortex in the name. Adrenocorticotropic hormone, or ACTH, is the primary regulator of both glucocorticoids and adrenal androgens, but it actually has almost no control over the secretion of mineralocorticoids. Mineralocorticoids, exemplified by aldosterone, are functionally a part of the renin-angiotensin axis, and are generally feedback regulated by the blood pressure. Again, that's a gross oversimplification, so be sure to check out the renal physiology section for a much better explanation. What is the germ layers the cortex and medulla are derived from? The cortex is derived from mesoderm, and the medulla, which acts almost like a postganglionic sympathetic nerve, is derived from ectoderm, specifically neural crest. So if ACTH controls the release of steroids from the cortex, what hormone releases catecholamines from the medulla? I'm just kidding, that was a trick question. Unlike most stuff in the endocrine section, this one doesn't work on the hypothalamic pituitary axis. Instead, it works a lot like the rest of the sympathetic nervous system. As you may remember, the SNS always involves 2 peripheral neurons, one preganglionic neuron that synapses onto a postganglionic neuron that then synapses onto a muscle fiber. In this case, the preganglionic neuron synapses onto the adrenal medulla, which releases epinephrine and norepinephrine, much like any other postganglionic sympathetic nerve. However, instead of secreting it onto a muscle fiber, the adrenal medulla secretes epinephrine and norepinephrine straight into the bloodstream. While we're on our fun little tangent back into autonomic land, anyone remember the neurotransmitter secreted by the preganglionic neuron? It's acetylcholine, and it's picked up by nicotinic ACH receptors. And that's going to be the same no matter whether you're in the adrenal medulla or in a postganglionic sympathetic neuron. You should be able to identify the various functional layers of the adrenal gland from a histologic specimen as well. If you can, try to orient yourself and figure this one out on your own. Remember, they may not give you a nice easy orientation, but you'll still be expected to recognize the cell types for the exam. Alright, time's up. Let's do this one together. So, the pathologists out there will probably not like my explanation for this, so I'll go ahead and address this right off the bat. Yes, the terms glomerulosa fasciculata and reticularis apparently refer to the histologic appearance of the cortical layers, and no, I've never been able to see it. The people who get this are probably just more sophisticated than I am, but I'll just tell you what I think is the easiest way to tell these apart. First, the capsule and the medulla are pretty easy to spot. The capsule is mostly collagen, with very few cells scattered around the inside, and the medulla is much more basophilic. It's got sort of a porous appearance to it due to the many vascular channels that are inside of it. So that just leaves the three layers of the cortex. Take a moment to try to demarcate those on your own, and let's see if you still remember the order of the cortical layers. So if the order is G, F, R, then the fasciculata is the middle layer, and I'll highlight it for you right here. So it's recognizable by its porous appearance, but unlike the medulla, it's not porous because it's highly vascular. It's porous because the lipid droplets, which are not preserved on the slide, appear like multiple little pores. Remember, the zona fasciculata produces cortisol, the eponymous steroid of the adrenal cortex, and therefore hoards the most cholesterol. The glomerulosa is closer to the capsule, and the reticularis is closer to the medulla. The reticularis actually contrasts really nicely with the medulla because it's very eosinophilic, or red-looking, and the medulla is very basophilic, or blue-looking. You got all that? Good, because now it's time for another flash quiz. What is the middle layer of the adrenal cortex, and what does it produce? And the answer is the zona fasciculata, which produces cortisol. Not so painful, right? Okay, I think that's about enough for the adrenal gland. Let's move on to the captain of the SS endocrine itself, the pituitary gland.